Hello, my name is David Castillo. I'm the CSO of BatchX, and in this video I want to show you how to use our genomic variant calling for UMI-based samples. So the first thing, we are in the menu, showing all the tools and pipelines in the platform, and we can go and filter for genomic variant, and this will leave us with two pipelines. This one is a more standard genomic variant. You can use it for genome, exome, and panels for NGS analysis. But for this video, we're interested on the UMI version. So let's click on that one. First of all, what are UMIs? UMIs are unique molecular identifiers, which are a type of molecular barcoding that provides error correction and increased accuracy during sequencing. This is especially useful when you want to achieve greater sensitivity on variant calling, right? Like being able to call variants that are less than 1% represented in the sample, which is the case for liquid biopsy samples, in which you are expecting to find cancer DNA, circulating cancer DNA in the blood, which is very low represented. I have provided some links on this documentation that you can go through if you want to find more about UMIs. So going back to the pipeline, these are all the tools that the pipeline orchestrates. It's quite a complex pipeline from the implementation point of view, but from a user, running analysis with this pipeline is pretty straightforward and easy. So let's go into the usage section, which we can see examples that you're going to be able to execute, right? So we have already provided an example that you can run without having to upload any data to the platform. So let's do that. Let's click on run and go to that example. From this screen, you can see that all the data has already been loaded. We are going to analyze two samples, but in your case, you can add as many samples as your study has, right? There are two modes in which you can analyze the samples. One is running the samples independently and obtaining a set of variants for each one of them, or you can run a joint analysis, which basically is going to generate a single variant table, separating the variants that you identify in each one of the samples, right? So for comparison purposes, this one is better. So let's once this is all configured, you can just click on submit, and this will take us to this other screen, right, where we can see the inputs and the outputs that the pipeline generates. In this case, I have already run this pipeline in the past, so BatchX is going to notice this, that I haven't changed any input and any parameter, so it's going to return the results that I obtained in the previous execution, right? You can see that the pipeline has already finished and I already have all the results. I wanted to show you how the original execution looks, right? Basically, we are getting the same inputs and outputs, but from here you can inspect all the actual tasks and jobs that were run in order to complete the pipeline, right? You can go through them, see how much time it took, what inputs each one of them required, and the outputs that they generated. You can also take a look at the graph, which basically shows you all the tools that were involved and how the data flow between the analysis, right? And finally, a timeline showing the jobs that the pipeline had to run, as well as the time for each one of them that it required. So going back to the job that we have just launched, we can briefly go through the results that the pipeline generated. Basically, you have quality controls for the read, standard FastQC analysis. You also get some histograms and statistics for alignment. Same for specifically for UMI analysis. The pipeline also provides the BAM files with the alignment reads, the BCF with the variance, and an annotated table, right? We use variant effect predictor for this because it gives us a very complete set of annotations for the variance. I've already downloaded some of these results so we can inspect them really quickly. We have, as you see, very standard program to be able to identify quality control metrics as well as any bias in our rates. We also have a plot of insert size metrics, right? We are working with a parent samples in this case, so this gives us a sense of what is the size of the molecule that was sequenced. We also have a set of plots with the distribution of coverage among the sequenced regions, right? So we can see that this is the raw coverage in the samples before considering the UMIs. So we can see that we have around 1,000 and 1,500 of average coverage. But once we perform the UMI collapse, which is a more representative coverage of the samples, we are left with around 120, 180 average coverage along the sample. Right? Previously, I also mentioned that the pipeline generates BAM files and the BCF files. This you can load them into a genome browser like IGB. And one thing that stands out is that we have very clean alignments, right? This is the alignment from one of the samples, and the other one we see very little noise on these reads, which allows us to, and this is a property this is something that you only see when you see UMIs, and this allows you to call variants, like in this case, even though with a lot of confidence, even though they are very low represented in the samples, right? So the last part of the pipeline that I want to show you is the annotation, right? We use Ensemble by an effect predictor. We have created a tool that grabs these functionalities, and it provides a very complete set of annotations, right, that go from the gene that is affected by the mutation, what's the impact at the genomic level, the codon level, the protein level, also different score annotation, polyphen saved. We also have allele frequencies in different populations, max allele frequency, and annotation for somatic annotations, as well as germline annotations for clean bar, for example. Right, so it's a very complete set of annotations. BEP also provides you with this report, which allows you to see what is the distribution of different types of mutations that were identified in the samples. The same, also a distribution on the consequences of these mutations. What is the coding effects, right? As well as other set of metrics and statistics that are very useful. So as you can see, this pipeline is very complete. It allows you to perform quality controls, perform the alignment, handle the UMI tags correctly, and identify variants that are at very low frequency, as well as annotations from variant effect predictor. So I hope you found this video useful, and yeah, looking forward to see you in BatchX. Bye bye.